6.4C lesson. We're on circles, angles, and scaling. All right, so we've got these two circles. It says that BC is a length of 5 units. Okay, and we're to kind of look at these, okay? Write a complete sentence explaining why the figures are scale drawings of each other. You may use a protractor, use words like corresponding angle, scale factor, corresponding side, circle. Okay, so it's important to understand that all circles are scale factors of each other. Okay, if you think of this guy with a bicycle pump in it, you would have this guy. Okay, so this is completely proportional to this, meaning there is a scale factor, okay, to go from this one to this one and from this one to this one. All right. The radius in the big one is twice the radius in the small one. All corresponding sides all corresponding sides in the big are twice the size of the small. Okay, so it's important to see that this side length, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so if this is twice as big as this and this is twice as big as this you can't count. Okay, it does tell us it has a length of 5 units. Okay, but you can't count the 5 units because it's kind of diagonal. Okay, but we do know that this is twice the size of this one. And if this one's 5, this one's 10 units. Okay. All right, remember that you've been given BC has a length of 5 units. What is the radius of each circle? Justify your answer. Okay, so if BC is 5 units, that is the diameter. So the radius is 2.5 units in the small circle. I think it wants us to do the big too. Yeah, what is the radius of each? Okay, so if FG is 10 units, that is the diameter. So the radius of the big circle is 5 units. Calculate the area of each triangle. Show your work. Area of the small. Okay, we know from elementary school 1/2 base times height is the area formula for triangles. So we're going to do 1/2. And we counted the base in the small one to be 4 and the height to be 3. So that would end up being 6 units squared. Area of the big. Okay, now let's think about this. We know that scaling, we know from a prior section that when a side length is doubled, the area should be 4 times as big. Okay, so I'm predicting 24 units squared is what the area of the big one is. Let's take a look. Okay, so the base of the big one is 8, and the height of the big one is 6. So that would end up being 24 units squared. Classify the triangles by the sides and their angles. So these are both scalene right triangles. All the side lengths are different. The angle at A and the angle at E are at a 90-degree angle, so that makes it a scalene right. Okay, what does the area of each circle show your work? Okay, well, we just found that the area of the small, we're going to use pi r squared, and we learned that r is 2.5. So that is, it doesn't say whether to keep it in pi, in exact value in terms of pi, or to do it in, what do you call it? Approximating. So I'm just going to leave it in pi. It's one less step. So 2.5 times 2.5 is 6.25 pi, and we are in units of some sort squared. And then the area of the big or large, so this is going to end up being pi, and the radius of this one is 5. So 25 pi units squared. How many times bigger is the area of the bigger circle than the smaller circle? So we can see here, the area of the triangle is 4 times as big, and then 6.25 times 4 should be 25. Okay, so 4 times bigger, since the scale factor is 2 for the lengths, and the scale factor is 2 squared then for the area. All right, next page. What is the circumference of each circle from the previous page? Circumference of the small is going to be pi times d. So we're going to pop in a 5 for the d. Hold on. Was it 5 for d? Yes, 5 for d. So 5 pi units. And then the circumference of the big was 10 pi units. Okay, how many times bigger is the circumference of the bigger circle than the smaller circle? 2 times bigger. Okay, since circumference is considered length and a length scale factor, and the length scale factor is 2. All right, fill in the blanks. When you enlarge a figure with a scale factor of 2, the side lengths and circumference double. The areas quadruple, and the angles stay the same. Okay, that's pretty key. All right, last problem. Draw a diagram to solve. A circle with radius 3 centimeters is enlarged, so its radius is now 6 centimeters. All right, so we've got 3 centimeters. centimeters. Okay, by what scale factor did the circumference increase? Show your work or justify your answer. Scale factor of the length is 2 since the radius is doubled. By what scale factor did the area increase? Okay, I'm not even calculating area. I know that it increased by 4. Scale factor of the area is 2 squared or 4, given that the length scale factor is 2. Explain why this makes sense using what you know about scale factor. Scale factor of area is always the square of the scale factor of the length. And let me move it over because my picture's in the way there. Okay, that's always the case. Okay, that concludes, guys, lesson 6.4C.